Well, thank you very much, Gary, for taking the time to do this. I really appreciate it.
No
So,
problem.
for those that are watching, Gary and I have been working together for some time now. Gary's a really experienced data scientist. He's spent a lot of his career going in and solving really complex problems. And I thought that he'd be a great person to do my first interview with. He can tell us a little bit about what he does and also give some really good advice to especially to companies that are looking to grow their teams. So yeah, thanks Gary, and tell us a little bit about yourself.
Thanks. Thanks for asking me, Zoe. I started off as a software engineer, and I did that for maybe about 15 years. I did software engineering, software architecture, application architecture, that kind of thing. And then about the kind of 2009, 2010 timeframe, I kind of got into data science. I think even before it was called data science, it was just probabilistic programming is what it was. That's how I got into it, through probabilistic programming. I thought, actually, this is really interesting. This is way more interesting than the usual kind of square, square, cylinder corporate architecture as it was back in the 2010 timeframe. And so I've been doing data science ever since. I did a bit on my own just as a contractor, and then I joined Microsoft for a few years as we had a wonderful job title at Microsoft. My job title was Cloud Solution Architect, open brackets, Advanced Analytics and AI, close brackets. So that fitted nicely on my business card, as you can imagine. So I did that for a few years, and then I left and I went back to contracting and consulting. So that's basically a potted history there.
So Gary, I know that you've worked on lots of really complex projects, and that's one of the reasons that I've done this interview. But tell me a little bit about an innovative project that you've done that's been really exciting for you.
Sure. I think probably the most innovative project that I've worked on recently was one that I did for National Highways. So I was originally brought on to build. So one of the things that I do is that I'll go into to organizations who say, "Hey, look, we want a data science team, and we want to set one up, but right now we've got nothing." So I'll come in and I'll build out their internet scale data science platform, and make sure it connects properly to their data. And then I will, if required, help them recruit the team and do some knowledge transfer and that kind of thing. So that's one of the services that I provide, and that was the service that I was asked to provide for National Highways. And once we built this thing, we were out. It was a lovely summer's evening, and we were out with the team that had basically created and built that thing that I designed. And we were just having a few beers. It was a lovely evening. We're chatting away. And one of the guys from National Highways who'd been seconded to the project, he was, I can't remember exactly, but it was something high up in the maintenance. And he said to me, "Well, now that we've built this thing, Gary, how do we get projects to actually do?" And I said, "Well, you have that funnel," and I kind of reminded him of what we built with the kind of funnel in at the top before we even start doing any data science. We have a kind of like an ideas funnel. You can think of it as being exactly the same as a sales funnel. You put ideas in at the top, everybody reviews them. You've only got a certain amount of time to get stuff done in any given period, and so you size those roles and you put a priority on them. You size the jobs. There's a priority. There's an amount of time, and then people decide what it is that you're going to work on. And I said, and the best way that I found to, I mean, everybody has their own way of doing it, but the best way that I found of filling that funnel is just to say to people, look, if you lived in a world where you could have any question answered, because that's all data science is at the end of the day. I mean, there's different kinds of data science. It covers a broad church, and there's lots of layers of complexity wrapped around that. But once you scrape away all the complexity and everything, at the end of the day, you're just answering questions. You're either answering questions about something complicated that happened in the past, where you say, "Hey, look, this complicated thing happened in the past. Can you explain it to me in a way that I understand it? Or you're answering questions about the future, and you say, well, what is the cost of cocoa beans likely to be this time next year? But you're just answering questions. And I say, the easiest way I've found of filling the funnel is to say to people, if you live in a world where you could have any question answered, what question would you have answered? And then that just goes in the funnel. And he said, well, and to be fair, we were a couple of pints in by this time. And he said, well, that's all very well. He said, but the real question that I want answered is impossible to answer. And at this point, I was like, nothing is impossible. Come on, then let's hear it. Let's hear it. What is your problem? He said, well, what I would like to do is I would like to know what the inherent risk in the strategic road network is. He said, and I'd like to know that for two reasons. He said, firstly, I'd like to be able to know what the inherent risk is in the strategic road network so that I can model the effects of different kinds of maintenance. So if I do different kinds of maintenance, if I do maintenance at different times of the year, or if I do maintenance on a different schedule, I want to understand what effect that has on my overall risk in the strategic road network. He says that's the first thing. And the second thing is, I want to know that because every 5 years, we have to go to the government and we get a certain amount of money for doing maintenance on the strategic road network. And he said, and right now, that is it's a qualitative decision-making process. I mean, we don't have any way of making it quantitative. So when we go to the government and say we need this amount of money, it's a qualitative decision that we've reached. And we need it to be more quantitative because when it's qualitative, it's very easy for the government to say, well, we see the number that you want and we're going to give you 70% of that number. And there's no real argument to be had because it's all qualitative and their opinion is just as valid as someone else's opinion. He said, what I want to be able to do is I want to be able to make that a quantitative number so that when the government say to me, this is how much money you're going to get in this 5-year period, I can say, well, coming into this 5-year period, the risk in the strategic road network is this. For that amount of money that I've asked for, I can maintain that risk. If you give me this amount of money, then the risk profile is going to look like that. Are you aware of that? And are you, do you understand the increase in the risk profile by only giving us this amount of money? He said, that's what I want to be able to do. And I said, well, that all sounds fairly, I mean, that's a complicated thing to do, but none of that sounds particularly difficult. And he said, yes, but we don't have any data. And I went, how do you mean you don't have any data? And he said, well, as an organization, we outsource all of our maintenance. So either data collection is part of an outsourced maintenance contract, but it's not an important part. If you're a contractor and you're asked to, for example, empty the drains so that they don't flood, that's the main part of your job. We also ask you to record how much water was in the drain that you emptied so that we can do that. Now, they may or they may not do that because that's a kind of secondary task. They may do it accurate. They may not do it at all. They may not do it accurately. And even if they do, we don't necessarily have access to that data because they have it as data and they give it to us as a report, not as the actual data. And even if we do have the data, it's probably in some siloed database somewhere that we would need 10 levels of permissions to actually access it for this project. So he said, for many reasons, he said, you can take it for all intents and purposes that we do not have any data. And I thought to myself, we maybe don't have any data. And I will be the first to admit, as a data scientist, the lack of data is, limiting.
Bit of an issue.
I'll give them that. Yeah, it's a bit of an issue. So I'll give them that. I said, but I don't believe that you don't have the data. I said, you have people in charge of maintenance. And he said, that's right. And I said, and never in the history of ever do I remember the strategic road network of the UK being completely shut down because stuff didn't get maintained. So the people who are engaging with these outsourced companies to actually do the maintenance must know what that maintenance looks like. Because it works. They're asking them to do it on a particular schedule, and it works right now. And so you do have that information in-house, albeit that it's qualitative information and it's in people's heads. And so what I did was I devised a methodology of taking that qualitative data that was inside subject matter experts' head, turning it into quantitative data, and then putting it into a modeling system. And that for roads networks was extremely innovative.
It's a long time.
I've since moved on from National Highways, but the team who are maintaining that, they were asked to present that solution to the Transport Research Board's national conference this year in Washington. So I believe the guys were away doing that. And also, it's very close to being published as in an academic paper. So that's probably the thing that I'm most happy with. Now, on top of that, one of the reasons I'm really happy with that is I took a whole bunch of learnings that I got from actually doing that work. And then, so I have that, I use that as a base. And then I said, well, what we did for National Highways would be better if, for example, you could express your uncertainty in these numbers. So basically what we did was we extracted your, for the want of a better word, your opinion on what the probability of failure was if you didn't do a particular type of maintenance on a particular type of asset at a particular frequency. And there's a whole process that I developed for doing that. But what we didn't do was we didn't in the original version, there wasn't an ability for them to actually layer on top of that their uncertainty about that number. There was no confidence. We took that number as a kind of group average, and we didn't express an uncertainty attached to that. And the other thing that we didn't do that I've since done is I've layered on top of that, I've layered on the ability to express what your appetite for risk is. So, for example, if you're talking about street lighting, there'll be a risk of that failing, and you might have quite a high appetite for risk of these things failing. You know, I'm not going to maintain it on this particular schedule, knowing that there is a, say, 60% chance of some of the lighting in my area failing. I will have a higher appetite for risk to that than if, for example, the lighting was in a tunnel or I was talking about median barriers or something like that. And so what this second version of that process is, I allow them to layer on top of everything else, not only their uncertainty, but their appetite for risk. And so different things, you can express a different appetite for risk for different things, and it's modeled slightly differently. And I've taken that kind of version 2 of what I did for National Highways, for example, and I've built this new process, and I offer that service to clients as well now. So I've kind of grown up a product out of that. So I think from something that was a 2 pint of beer fueled conversation turned out to be something pretty impressive in the end. So that's probably what I'm most proud of.
Yeah, definitely. I can see you've made a massive difference, and it's really impressive that yeah, they're looking to publish the papers on it as well.
Yeah, it's good.
So if you had a company come to you, which we get all the time, and they said to you, I want to set up a data science team, what things do I need to consider? What do you think you'd say to them?
First of all, I'd ask them to consider why it is they want to do that. If it's just because if it's because of what I call magazine management, where you can imagine a high-ranking executive on his commute into work has been flicking through their industry magazine and everybody's talking about AI, and he said, well, everybody's talking about AI, I want to get into that, right? That's a really bad reason for getting into it. So what I would do, so first of all, I would ask you to examine your motivations for getting into AI. Now, just because you've seen it in a magazine is a really bad reason, but some of the reasons which are adjacent to that are actually quite good. So reasons which are adjacent to that are things like I'm currently the market leader, or I'm currently the second or third operator in the market, and I believe that if we had a data science team, that would give us the edge to be able to be the leaders in the marketplace. That's a really good reason and is adjacent to magazine management. Another one which is also adjacent is I know that some of my competitors are getting into this space and I don't want to get left behind. That's a good reason.
Yeah.
And another reason, which is adjacent to magazine marketing, is this is coming. It's coming everywhere. Nobody really in my organization or in our market is really jumping into this right now. So I think by jumping into it now, we can get an advantage over everybody else because it's coming. It might not be this year, might not be next year, but it's coming. So I want to get ahead of the curve. So these are all reasons which are adjacent to the kind of magazine market management that you want to stay away from, but are actually good reasons for getting into it. So the first thing to consider is why you want to do that. And once you understand that you do have, once you've identified that you do actually have a good reason for getting into it, then you can get on to you can get on to the next stage, which is, do I have a vision for what this is? So sometimes I go into customers and customers have a clear vision of what it is that they want to do. They want this thing set up. They want an internet or a cloud scale data analytics platform. They want it properly serviced. They want the data attached to it. These are the problems that they're going to tackle. They have a very clear vision. Sometimes they don't. They just have this idea that, hey, for example, hey, AI is coming to our marketplace. I want to get in now so that I can make the mistakes early while they're least expensive and I can get a jump on my competitors. That organization has no vision. They have a goal, but they don't have a vision. And
Yeah.
so one of the first things you should do is to hire somebody like me, not necessarily me. There are many people like me, somebody like me who can take your goal and then actually describe a vision of how you achieve that goal.
Yeah.
So that's the next thing to consider is if you don't have a vision, get somebody on board who can actually take your goal, turn it into a vision, and then push that forward. And then the next thing to consider is your data. Is your data in a place where you can actually start doing data science on it? And if it's not, that's something else that you need to consider. And then once you've got all those ducks in a row, now you can actually start talking about, okay, let's kind of build a team. What kind of skill sets do I need in a data science team in order for it to function the way I see this vision or this goal getting achieved? And so those are basically the kind of linear steps that you need through your thinking. And those are the things that you'd have to think about.
Yeah, yeah. And actually just for a point, one of the things that I tend to see a lot is, one of the main factors is the buying as well from the rest of the team. As the rest of the company is really important, isn't it?
Yeah, absolutely. I mean, especially so. I'm actually seeing this. You know what people say. By the time you're mature in your career, you see the same things over and over. And what I'm saying is a repeat of the same kind of things that we saw in the early 2011, 12, the early naughty teens, as it were, up to about 2015, where we're trying to do digital transformation. We're trying to get people to move out of data centers into the cloud for various reasons. And one of the things that we came across is people who had a lot of years invested in an organization and their empire and power came from the fact that they ran the data centers. And now we were coming along and saying, well, we're going to move all of that stuff into the cloud and your empire is going to disappear. So you either get on the train and retrain to do the job that you're doing now in the cloud, or you've got you have a problem in the future. And a lot of these people went, yeah, I'm not doing that. This is my department, and I'm going to fight you every step of the way. And that took a bit to overcome in the kind of middle naughty teens, as it were. We're
You
saying
still
that
see it now. You still see it
you're
now at the
saying
end of the
exactly the
day.
same thing now when we want to say, hey, we're going to move the data, we're going to move your data into the cloud. And the first thing that I come across, which I think, and it always makes me smile, is people say, I don't know. I don't, I don't know about that. I mean, there's all kinds of problem with security, in the cloud. And I'm like, dude, I will guarantee you that your data is provided it's done properly, but you can see the same thing for a data center, right? So assuming that everybody working on these projects are competent at their job, I will guarantee you that your data is way more secure in an Azure data center than it is in your data center down the road. 100%. if anybody's listening to this and you ever get the opportunity to go visit an Azure or an AWS data center, take that opportunity, because they are incredible places. And I've never seen anybody come back from one of these tours going, no, 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 I'm convinced still that our data is far safer in our data center. They all come back going, get our data in there as soon as you can. But there's still a certain amount of resistance. And it was the same resistance that we encountered when we were doing digital transformations back in the naughty mid-teens.
Definitely. So if a company was, first time setting up a data and analytics or a data science function, like how quickly do you think they could see tangible results? Because I've built data science teams from scratch, and it seems to really vary. But I did see on one occasion, I think within a year they'd saved hundreds of thousands of pounds, and that was a particularly good decision for them to make, to have set up that team. But I think sometimes I see sort of senior individuals assuming that changes and like amazing things are going to happen within the company overnight, and it doesn't always work like that. So what do you think? What's realistic?
Yeah, that's a really good question. And I think it kind of the answer to that question turns on how do you measure success?
Yeah,
So
yeah. So
if you're
in that case,
seeing
it was saving money, but yeah, there's lots of things, isn't there?
exactly.
Yeah,
So if you're saying, well, I'm only going to measure success, I'm only going to measure the success of this data science team by the financial reward. Either I want to see money saved, or new opportunities coming out that I can make money on. So I want to make money on stuff, or I want to save money, and that's my only measurement of success. In that kind of measurement landscape, you're talking 12 to 18 months,
yeah.
maybe even closer to 18 to 24 months, for the very
Mhm.
reason that you have to build a thing, you have to put the thing into production, and then your accounting period is a year. So you don't really know until the end of that accounting period how much money it saved you, or if it saved you money at all. Some people say, oh yeah, but you can tell from quarter to quarter. Well, you can. I mean, in the first quarter, it might save you X amount, but in the last quarter, it might cost you money. And so you need the full accounting period. And since full accounting periods tends to be a year, you're not really going to have a good understanding of the financial consequences of having your data science team in place for at least a year after you put the first product that you've built into production. And that could be 6 months to a year anyway. So you're really looking at 18 to 24 months if you're only going to measure success on financial gain. However, if you want to measure success on, I can do things today that I couldn't do yesterday, then you can get success from your data science team almost immediately. So you can say, for example, I have this question, because we talked about before how data science is basically just answering questions. If a CEO has a question and you say, and they have no idea how to answer it, they have no idea even how to proceed. And you can come along and say, well, using the data that we've hooked up and using this data science platform and using the team, I'll get somebody in the team to spend a couple of hours looking at this. And then within a couple of hours, I'll be able to tell you whether this question is answerable with the data we have. So some questions are answerable straight away. It's like, yep, I understand that. We've got the data. I can see a way to answering that question. Some questions are not answerable because you don't have the data or access to the subject matter expertise, in which case you can come back and you say, we can't answer that data just now because we're not capturing that data yet. However, if we capture that data and we have that data for X period, then that question is answerable. Or you can come back and say, no, that question is not answerable in any meaningful way because there's far too many variables that we'd have to deal with. And although we can answer the question, the actual confidence bars would be so far apart as you'd be better just guessing, to be honest. Now, you can have that answer within a couple of hours. Like an afternoon of working will be able to to answer you that. Now, that's a success for that team because prior to having that data science team in place, the CEO had the question and no one had a clue what the answer was or even how to answer it. And so there's your answer is anywhere between a couple of hours to a couple of years, depending on how you want to measure success.
Yeah, I really like that, Gary, because I think, a lot of people do measure the success on, how much money has it saved the business or how much money has it made the business, like you said. But actually, there's a lot more to it than that. And yeah, I think that would be really good for people to hear. And it's definitely one I'll be using when I speak to people. So thank you so much.
Yeah.
So when a company's building this team, um, what subject matter experts are going to make up a data science team, do you think? Because I mean, let's face it, it's not just going to be a load of data scientists, is there? There's lots of things to look at. So what sorts of people do you think they'll need to bring into the business? You've got your data engineers, data scientists, who else?
So yeah, that's right. And when I'm talking to clients about the kind of people that they will have to hire or the kind of skills that they will need, you don't necessarily have to hire people in. You can retrain existing staff. So I like to talk about skills, not necessarily people.
Okay,
But
yeah.
when you're talking about skills and you're trying to understand what skill set you require, the easiest way that I've found to explain it is just to follow the data. It's like, so you start with your data. Well, what state is your data in? Do you have fully conformed data lake and data warehouse? Do you have that already? If the answer is no, so let's just assume all you've got is your working day-to-day data, your ODS layer, like your operational data service, and that's all you've got. So if you want to answer the question of what skills I need, then you have to follow that data. Okay, here's my data here, but that's the data that just runs my business. All right. So the first skill set that you need is you need some data architecture skill set because you have to be able to look at the setup that you've got at the minute and then architect what a reporting and data science data warehouse and data lake would look like. So you need somebody to design that. And then once it's designed, you need somebody to build that. So you need data engineers, cloud architects, cloud engineers in order to be able to build that thing. And then once you've got that thing built, you can start doing some data science. Now, not every data scientist will be able to look at a fully conformed data lake or data warehouse and know exactly how to extract the data they need in order to do the particular bit of data science they want. So again, you need data engineering skills for a data scientist to explain to a data engineer the data that they need in order to be able to answer a business question. And then that data engineer will go away and extract that data. So basically drain the data lake. That's why they're called lakes, because you drain them for the purposes that you need them for. I always thought they should be called reservoirs because you don't tend to drain a lake. But anyway, nobody asked me, so they're data lakes, right?
That's interesting because
So
I
you
always
drain the
wondered
data
why they were
lake.
called lakes.
Yeah, exactly. So if so you want to drain that data lake into the particular purpose that the data scientist needs the data for, you need a data engineer to do that. Then the data scientist can do the data scientist's role and come up with the answer to the question. And then very importantly at the end, you need somebody with visualization and storytelling skills in order to present the answer to that question in a way that is consumable by the rest of the business. Because what I always tell customers is if you have to be a data scientist in order to understand the output of a data scientist, then you're missing a skill set. And that skill set you're missing is the visualization and storytelling skill set. So somebody who
Mm.
can take that result and then turn it into, it might just be reports, but it might be, charts, it might be dashboards. However, you need somebody to take that work and make it consumable to the non data science subject matter experts in the rest of the business. And so that's the best way to think about the skills
Mm.
that you need. It's basically just follow the data. Instead of follow the money, you follow the data from where it is now to the consumption at the end.
Brilliant. And yeah, something which I often get asked a lot, and I think I know the answer to this one, is what comes first, and that's, would you say it was the data scientist or the data engineer? if you're setting
So
up a team. I know that so in my opinion, after seeing a lot of teams be set up, it can vary depending, like you just said, on the data and what needs doing. But I often see mistakes made where a data engineer is taken on and then later, sort of a bit further down the line, they realize, sorry, a data scientist is taken on, and then a bit further down the line, they realize they should have taken on a data engineer first.
yeah,
Do you
so
find
it's a
that or
yeah, so it's a function of two things. I would agree with that broadly, but more specifically, it's a function of two things. One is what's your maturity model like on the way to having this fully set up data science team? Um, if you're very mature, you might not necessarily need a data engineer. So if you have all of your data conformed and it's there in a data lake, and it's there in the data warehouse and things like that, so you are mature in terms of your data infrastructure for data science,
yeah.
then you might not need to hire a data engineer in the first instance. So that's one thing it depends on. And the second thing that depends on is what type of data scientist have you hired? So people who are more mature in their data science careers, like myself, we started off doing data science before there was the great split of skills. So people like myself or people of my era, we had to do everything. So we had to do data architecture, we had to do the data engineering, we had to do everything because we data scientists were seen. If you go to Google and ask a Google image to Google the intersection of the skills of a data scientist, and you'll see them from back in the early naughty teens. You see them all with this massive intersection of programming and data architecture and storytelling and visualization, and the data scientists right in the middle. So those are really data scientists of my area, my era, and my maturity. Now, if you get a data scientist like that, then provided everything's providing all things are equal, then that's what you need. But there was
Yeah.
this about the 2015, 16, 17 timeframe. There was this great split of skills, and there were data scientists and data engineers and all the rest of it. And so, if you
Yeah.
hire a data scientist who's newer in career, then data science is really the only skill that they have. And with that, you need to put the supporting skills around that. And one of the supporting skills, is you're right, is data engineer. So in that case, if you hire a newer in career data scientist, the kind of supporting skills around that you have, and in the order that you would hire them, are data engineers in order to drain the lakes that you have, data scientists in order to do the data science, then cloud engineers in order to put the model that data scientist builds into production, and
Hmm.
then storytellers in order to make that available. So that's the kind of supporting roles. And like you say, who comes first is the data engineer. Unless you can find a mature data scientist who can do the whole thing, and in which case you really just need the data scientist. Although you will still need the supporting, you'll still need the supporting skills at the point where you decide to go into production. So if you get a more mature data scientist, he'll be able to do everything for you in terms of proof of concept. But at the end of the day, then that person's then going to be a bottleneck for actual production. Because sure, I can speak to somebody in the business, I can get a data science question, and I can literally do everything from taking your data from the the systems you've got to run your business right up to generating dashboards and reports in Power BI or Tableau or whatever. I can do that whole thing end to end, but then there's only one of me. And if I'm doing that, I'm not doing anything else. And so a more mature data scientist with all of that skill is fine right up to proof of concept. Okay. But once you want to put stuff into production and you want a pipeline of things going into production, obviously you need those broader skills so that you can kind of parallelize the tasks. And then the order would be, as you say, data engineer, data scientist, cloud engineer, visualization expert / storyteller.
Yeah, definitely. Yeah, and one thing I noticed as well, depends on sometimes the size of the team or the size of the company that they've come from as well. Because, if someone's worked in, startup capacity, they probably have a much broader range of
Yeah,
skills for going into a team. So yeah, there's lots of different types. I mean, so many different data science. It's a bit of a grey area, really, isn't it, at the moment? Let's face it. There's so many different skill sets within that one job title, basically.
yeah, 100%.
Well, yeah, thank you so much, Gary. That's been really, really helpful. I'm sure lots of people will find that helpful. And yeah, if anyone watching is looking to set up a team and they need some help, obviously you can speak to Gary. Gary is a contractor and loves working on complex projects, as you might have guessed from today. So um, yeah, thank you so much, Gary. I really appreciate it.
No problem, Zoe. Thanks a lot. Thanks a lot for asking me, and I hope everything goes well for you.